Hello, my dear students of class 10. This is Priyanka Upadhyay, and today we are going to learn a second chapter, that is Work, Energy and Power from ICSE Class 10. Today, in this session, we are going to learn meaning of work, measurement of work, units of work, expression of work, conditions for the work done by a force to be zero, and the work done by the force of gravity, that is W is equal to mgh. So, in the beginning, just let me explain you what is work. In our daily language, we use the word work many times while reading, while writing, while playing. We say that we are doing work. But in physics, it is something different. See, whenever we are doing something and we are applying some force and we are moving some objects. In this case, we can say that we are doing work. See here, in the first point, it is mentioned when we apply force on a body and make a displacement, we say that the work is done. So it means when you apply force on a body or an object or a person, what happens? The body makes the displacement means it moves from its point to position to another position. So in this case we can say that we have done the work. So in this picture you can see that this man is carrying boxes. Okay, he has lifted the boxes and he is moving. So in this in this photo, we can just say that the man has done work because he has displaced the boxes after the application of force. So in this picture, you can see that the man is applying force on the wall. But the thing is, wall is not moving at all. So whether he has done the work or not, what is your answer? Okay, the answer is no. He has not done any work because there is no displacement. If you want to do work, there should be a displacement in the body. So again, we will come here. So work is done when force is applied on a body and displacement takes place. There should be a displacement. Next point, if there is no displacement of the body, even when a force acts on it, the work done is said to be zero. Okay, so in the second case, in the second picture, you have seen that the man was applying force on the wall. Even though there was a force on the wall, there was no displacement. So it means work done would be zero. Okay, so what is the definition of work? Work is said to be done only when the force applied on a body makes the body move. It means that is there is a displacement of a body. Okay, so next thing, so this work is a physical quantity, so we can measure the physical quantities. So how to measure the work? The amount of work done on a body, it is dependent upon two factors, that is nothing but force and displacement. First one is magnitude of force. Magnitude of force is nothing but the amount of force. Second one is displacement produced by the force. It means how much the body has moved from its initial position, that is displacement. So the work is given by the formula W is equal to F into S. F is nothing but force and S is displacement of the point of application of a force in the direction of force. So this displacement should always be in the direction of force. We have to take the displacement in the direction of force or force in the direction of displacement. Okay, here you can see the last point. If a force acts on a body and the body does not move, that is displacement would be zero, then there is no work. Okay, see here. As the formula says, W is equal to F into S. If there is no displacement, means S is equal to 0. Then automatically, if you substitute that S is equal to 0 in this formula, you will get that W is equal to F into 0 is nothing but work done is 0. Okay, so can we say that the work done is a vector quantity? Do we have any direction for it? I think no. Not I think, actually it is not no. Work done is a scalar quantity. It doesn't have any direction, and force and displacement are the vector quantities, but dot product of two vectors is a scalar quantity. Therefore, work done is also a scalar quantity. In simple language, we can say that work does not have any direction. So that is the reason work is a scalar quantity. The next thing is unit of work. So here unit of force is Newton, unit of displacement is meter, and unit of work is joule, that is Newton meter we can give. So next one is expression of work. So we have to find the expression of work. So how to find the expression of work? Either we have to find the force in the direction of displacement, or we have to find the displacement in the direction of force. In this picture you can observe that here force is being applied. Here at the look at the arrow, look at the pointer, see force is being applied along AB, but the displacement is along AC. Okay, sometimes it happens. See here, sometimes what happens, force displaces the body in a direction other than the direction of force. In an inclined plane, you can see that if you are applying force in the forward direction, but the body moves in a inclined plane, moves on an inclined plane. In this condition, see here, what we can say? We can say that the force displaces the body in a direction other than the direction of force. You are applying, in this picture you can see you are applying force along AB. Okay, that is in the forward direction, but the body is moving along AC, that is on the inclined plane. Okay, so in this case, how to find the work done by the force? So we can find the work done by the force in any of the in two ways. That is, either we can find the component of displacement in the direction of force, or the component of force in the direction of displacement. Okay, students, now we will find the work done by finding the component of force in the direction of displacement. Okay, so in this figure, you can see that here is the component of force. This is the component of force in the direction of displacement. This is the direction of displacement. So we are going to find the component of force in the direction of displacement. So for this, what we have to do? So here, in this picture, you can see that PA represents the magnitude and direction of force acting on the body. This PA represents the magnitude of force and direction of the force which is acting on this particular body. Then the component of force in the direction of displacement. Then the component of force in the direction of displacement, that is in the direction of AC, would be NA. This is the component of force in the direction of displacement. Now we know that work done is force into displacement. So work done is equal to force into displacement. So what is force? See here, what is force here? NA is the force, component of force in the direction of displacement. So NA is the force into AC. AC is nothing but the displacement of the body. It has shifted from A to C. It has displaced from A to C. So NA you will write as it is into AC. Displacement is nothing but S. So from the right angle triangle PNA. Here is the right angle triangle PNA. Just look at this pointer PNA. This is the right angle triangle. In this triangle, if you are considering theta, okay, so theta, if you consider cos theta is equal to cos theta. How will you write cos theta? Cos theta is equal to NA divided by PA. Cos theta is equal to NA divided by PA. That is nothing but NA is equal to PA into cos theta is equal to F cos theta. PA is nothing but force which is acting. Okay, force which is acting on the body. So PA into cos theta. PA is nothing but F cos theta. This F cos theta we are going to substitute in this equation, that is W is equal to Na into S. So now we know the value of Na, that is nothing but F cos theta into S. So this is nothing but W, that is work done is equal to component of force in the direction of displacement, that is F cos theta into displacement S. Okay. Okay, from these two equations, we can infer that work done is equal to product of magnitude of force. Here you can see product of magnitude of force, that is F into displacement. Second one is magnitude of displacement, that is S magnitude of displacement. And the next one is cosine of the angle theta between the direction of force and displacement. So this cos theta, F into cos theta, F cos theta into S, or here you can say that F into S cos theta. In this you can see that F is the component of force, S is the magnitude of displacement, and cos theta is the angle between the direction of force and displacement. Okay. Okay students, now we have some special cases. In this we will study that when the work done will be zero, positive or negative. In the first case we will learn about the work done when it is said to be positive. Okay, the condition is if the displacement is in the direction of force. Okay, then theta will become 0. Then cos theta will be equal to 1. Okay, in this picture, you can see that, see, the man is lifting the object from the ground to above. Okay, in this case, the force is in the upward direction and the displacement is also in the upward direction. So here, there is no angle between force and displacement. In this condition, theta will be 0. Hence, cos theta, that is cos 0, will be 1. Therefore, if we substitute this in W is equal to F into S cos theta, you will get W is equal to F into S. So in this condition, we can say that the work done is positive. Okay, so first example, okay, when a body falls freely from a height h. See, this is the height h. So this is the body of mass m which is vertically falling down with the acceleration due to gravity. Here, force of gravity would be F is equal to mg, that is mass into acceleration. F is equal to mass into acceleration. The displacement from the initial position to the final position, the displacement is nothing but the distance, that is height s. Okay, next if you substitute this in, the work done is equal to force into displacement. Work done is nothing but W. Force is force on the body would be mg, that is mass into acceleration due to gravity, because it is freely falling down. Then displacement would be the height h. Therefore, W is equal to mgh. Okay. So now, when a coolie does work on the load, when he raises it up against the force of gravity, this man is raising these boxes up against the force of gravity. Both the forces, force exerted by the coolie, that is mg, mass into gravitation, and the displacement. Displacement is also in the upward direction and force is also in the upward direction. So in this case, okay, in this case, we can say that the work done by the coolie in raising the load would be W is equal to mgh. Please go through your textbook. Okay, second condition, case 2. In this case, it says about if the displacement and the force are normal to each other. What happens when the displacement and the force are normal to each other? When the displacement and the force are normal to each other, the angle between them would be 90 degree. See here, This man is carrying weight on the top of his head and he is moving forward. Okay, just imagine that you are carrying weight on your top and you are moving forward. Here you are applying force in the upward direction and you are moving forward. So in this case, force is in the upward direction and displacement is in the forward direction. Here, the angle between the force and the displacement would be 90 degree. So cos 90 degree would be 0, and hence, if you substitute this value in W is equal to F into S cos theta, your answer will be W is equal to 0, because cos 90 is 0, so everything will be 0. Here in this condition, the work done would be 0. For this, the example is this man itself, a coolie who is carrying force, who is carrying load on his head and he is moving forward. No work is done against the force of gravity because displacement of the load is normal to the direction of the force of gravity, which is vertically downwards. Okay, students? So the third condition is, what happens when displacement is in the direction opposite to force? When displacement is in the direction opposite to force, the theta would be 180 degree. Listen here, the force of gravity would always be acting downwards. When you throw a ball vertically upwards, what happens? You are doing force against the gravity. Negative work done by the force of gravity in upward motion. See here. When a ball of mass m is thrown upward, this is a ball of mass m, it is thrown upward from A to B. Here you can see to a height h. The displacement is opposite to the direction of gravity, force of gravity. The force of gravity is downwards. The force of gravity is acting downwards towards the center of the earth, and the displacement is in the opposite direction. Now, work done by the force of gravity, we can give W is equal to F into S into cos theta. In this case, F is nothing but M into G, and S is nothing but the height, displacement, that is height. So cos theta. So both are in the opposite direction. Force and displacement are in opposite direction. So angle between them would be 180 degree. So cos 180 degree would be -1. Hence, if we substitute this in W is equal to F into S into cos theta, you are going to get W is equal to minus F into S. Okay, so in this case, we can say that the work done is negative. So the last point is condition for the work done by a force to be 0. When a force will become 0. From these above discussions, we can clearly say that the amount of work done by a force is 0 in the following two situations. When there is no displacement. See here, when there is no displacement, even if you are applying force on the body, in this condition, work done will become 0. And the second condition, when the displacement is normal to the direction of force, when the displacement and the force are normal to each other. In this condition, theta will become 90 degree, cos 90 degree will become 0, and the work done will become 0. Here are the two cases, okay, for which the work done by a force will become 0. Okay, next one is work done by the force of gravity, that is W is equal to mgh. So already we have studied this. One more time we will go through it. See here, let a body of mass m be moved down through a vertical height h, either directly or through an inclined plane. Whether the body is coming directly or from the inclined plane. So in this condition, okay, So the force of gravity on the body would be W is equal to mg, which is acting downwards, and the vertical displacement in the direction of force S is equal to h. Even if you are coming from an inclined plane, so the displacement would be in the direction of force, that is S is equal to h. Hence work done would be force into displacement. Force is nothing but mg and displacement is h. Therefore work done by the force of gravity will become W is equal to mgh. Okay, here we have stopped discussion about work, and in the next section we are going to study about power. Okay students, bye, take care.